Welcome, everyone. My name is Vlad Vlaschano. I'm a solutions architect for Amazon Web Services. And my job is to help customers make effective use of AWS services. So right now, I'd like to thank each and every one of you for choosing to spend one of the last few hours before the reInvent party with us here tonight. I know it's been a long day. It's been an exciting week with a lot of great announcements. How do you like reInvent so far? Awesome. We've seen a great couple of announcements, which I personally think is going to make running Microsoft SQL Server workloads on AWS really, really fast. So today, I'm here to show you how you can operate SQL Server workloads on AWS effectively. It's been a busy year for a lot of us here at AWS. And we've come up with several great features that help customers run SQL Server on AWS easier, with higher performance, and less management overhead. So I'll spend a few minutes outlining what the options are for running SQL Server on AWS, focus a little bit on licensing as well, and then we'll quickly change gears and focus on best practices. So over the last few years that I've been talking to customers and helping them with Microsoft SQL Server workloads and other types of workloads in general, I've realized that a lot of customers typically have the same sort of challenges, right? And what we're hoping to do today is provide you with some guidance and some best practice patterns on how to address some of those challenges that seem to be very common with a lot of folks that want to run SQL Server effectively on AWS. Please hold your questions until the end of the session, and we'll be happy to answer them as well. So let's talk a little bit about how to run SQL Server on AWS. Many of you, I'm sure you know, there are several ways to do it. How many of you are running SQL Server on AWS today? Pretty much the entire room. That's awesome. How many of you are using EC2 and running your own SQL servers? The wide majority, okay. Is there anybody that's running it on RDS? Also a lot of you. So that's great to hear. So those are really the two main choices and the two main options you have to run SQL Server on AWS. You can leverage RDS and provision fully managed database instances, or you can deploy your own SQL Server on EC2, which is pretty similar how you would do it in a data center as well. Rather than running it on your own virtual hypervisors and virtual clusters in the data centers, you can run it on EC2 instances on AWS. The types of features and the types of challenges you would have are fairly similar, right? And many of you have heard this week a lot of talk about, managed services, about eliminating undifferentiated heavy lifting. These are typically the types of activities that customers would do that don't necessarily bring value to their businesses, right? Everybody has to manage somehow backups, maintenance, patching, and all those things. That in and of itself isn't necessarily a competitive differentiator. It's not something that gets you ahead of your competition, right? So RDS offers an environment where we take care of all that for you. So we provide managed physical infrastructure. We manage the database installation as well as backups, as well as maintenance, the OS patching, and we provide a managed high availability option. This is really great for a lot of customers, and a lot of you are already taking advantage of that, which is awesome to see. That said, many of you like having operating system level controls. So running on EC2 also gives you some level of managed physical infrastructure. You can also take advantage of instances that AMIs that already have pre-installed SQL Server. Scaling is somewhat managed in the sense that you can easily with a simple few clicks, you can move up and down between different instance types. But at the end of the day, the majority of the day-to-day operational work that you'd have to do, you would have to do yourself. So your area of responsibility is much greater whenever you're running on EC2 than on RDS. On RDS, you would focus on things that truly bring value, right? Application optimization, tuning your queries, making those more efficient, making sure that you're deploying your clusters in an automated way. Automation, you've heard today, is this week is very kind of big, a lot of adoption in that area, and focusing on monitoring those systems. Well, you kind of have to do all of that with EC2 as well. But on top of that, in addition to that, you also have to worry about high availability, which is really, really tough to do in certain situations. Backups, database, and operating system patching. So we recommend you consider RDS first, right? If you're deploying new workloads in the cloud using cloud-native technologies and services and features and architectural best practices, what we like to kind of refer to as a cloud-first policy, RDS just makes sense. It facilitates that and offers some very key advantages, right? Yet there are very good reasons why you as a customer would want to deploy your own SQL servers. Some of you may need that full control of the operating system level or of the backups or of the replication strategy. Some of you may be running legacy workloads that you can't exactly change, but they do need that level of control. And in those cases, EC2 would be a better fit for you. Likewise, EC2, running SQL Server on EC2 is a good fit when you have to take advantage of SQL Server features and options that we don't make available through RDS. Because RDS is a managed service, we have to ensure a consistent experience and a consistent level of performance to all of our customers. So typically options and features that would impact our ability to do that in any way are not generally available on that platform, such as access to the sysadmin role, or the ability to run SSRS, SSAS, or SSIS on the instance itself. You can still use RDS as a data source for those, but running those services actually on it is impossible. However, that list of features, this discrepancy between the feature set is constantly shrinking. As we're working to find ways to actually even bring those types of capabilities to the RDS platform, over time this list of features shrinks. Just this year, we've launched support for Windows authentication and native backups, which were previously unsupported on the RDS platform. So when you're looking in terms of key features, you see a lot of overlap here. So the same modern versions of SQL Server are available on both platforms. You still have access to some of the 2005 and 2008, some of the older versions of SQL Server. On EC2, you can install them yourselves, but generally the same versions are available on both. Same goes for the additions. One of the key differentiators is high availability, and we'll talk later a little bit in more depth about the options there. But generally, we take care of that on RDS, whereas on EC2, you would have to implement that yourself, either using always on, failover clustering, mirroring, log shipping, or whatever combination of features. Encrypted storage is really a great differentiator. It works on both platforms, and it works for all editions of SQL Server and all versions. We offer encrypted storage using AWS KMS. So having an encrypted database is no longer the domain of Enterprise Edition using TDE, although you can certainly use that. Windows and SQL Server authentications are available for both platforms. And just kind of following the pattern of the managed service, we take care of the backups and the maintenance activities for you, whereas you would have to deal with those yourself on EC2. Just like there's two options for running SQL Server on AWS, there's actually also two different options for licensing on AWS for SQL Server. So you can either use the licensing included model, or you can bring your own license, what we affectionately call BOIOL. So using SQL Server under a license included model is very, very easy. If you're using RDS, you simply choose that as an option whenever you launch the cluster. In the console, it's a drop-down. It's typically the default parameter if you're launching from the command line or any other tools. On EC2, you simply use one of our machine images that have SQL Server pre-installed on them and start running it, and start configuring it and loading data on it. So what that does is you are paying for the SQL Server license, part of the hourly cost of that instance. And you're only paying for the SQL Server license for however many hours you're actually running that instance, which becomes very, very compelling if you actually don't run fully 24/7 on those instances long term. And it's available for Web, Standard, and Enterprise editions. You can also bring your own licensing to both Amazon RDS and Amazon EC2 in default tenancy if you use software assurance with the license mobility benefit. So in that case, you would have to submit a verification form. It's an online form available on our website. The data is sent all the way to Microsoft to verify your benefit and the license availability. And at that point, you can actually run SQL Server on AWS and use your own licenses. Now, license mobility isn't the only way you can actually bring your own licenses. So if you have some per core or per socket licenses, or you don't have that benefit, that license mobility benefit, you can still bring SQL Server licenses to AWS. However, you will have to use Amazon EC2, and you would have to use Amazon EC2 dedicated hosts. So that's an important distinction. Now, of course, if you're unsure about what sort of licensing you have, or whether you have the license mobility benefit, you want to verify with Microsoft. They're going to be the authoritative source as far as what you can do and what is permitted within the licenses that you're actually having. So let's dive deeper into best practices for SQL Server. And we'll focus on EC2 first. What are some of the main pain points that you guys are having whenever you're running SQL Server on AWS? I'm willing to bet that probably storage and configuration and storage performance is pretty high up on everybody's lists. So we'll focus on that. We're also going to discuss tempdb. And then the second area where I see a lot of customers having questions and potentially struggles are implementing high availability for SQL Server on AWS, on the various editions that are available on AWS. So in AWS, there are two main categories of block storage. And I know many of you already know this. The most pervasive one being EBS. This is networked attached block storage. And in recent years, we've made significant investments in the offering and advanced the feature set and improved the performance to the point that it actually can exceed in certain use cases the performance of direct attached storage for certain instance types, while offering much, much better data durability. So EBS is available for all your instances. And in fact, most of the higher performance ones come with EBS optimization. This is really key for running database workloads in general, specifically SQL Server. It gives you a dedicated channel for network storage I/O. So it eliminates contention from the instance with regular network I/O traffic. And the size of that dedicated channel depends on the instance type, but it can go as high as, just announced yesterday, 12 gigabits per second with the new R4 instance types. And while some instances offer EBS optimization, Other instances are EBS optimized by default, and yet other ones, it's an option that you have to actively enable. So you want to make sure whenever you're launching SQL Server, you understand which instance type it is, whether it supports it by default, or whether you actively have to check that box whenever you launch that instance, or set that right flag whenever you programmatically launch it. There's 4 current generation types of EBS volumes, not counting a legacy magnetic volume type. 2 are SSD-based, and they're designed for general purpose or high-performance use cases. These are use cases with high IOPS for random I/O. There's also 2 volume types that are magnetic, and these are designed for use cases for large sequential read and write throughput operations. So the last 2, the magnetic ones, they're not very good for hosting database files, but they can be very effective in support roles for your databases. Most folks will start deploying SQL Server under general purpose, using general purpose SSD. This works fine for most use cases where the load is somewhere average to high performance, but the key there being that it's variable, right? So there's some variability where you have spikes, you have valleys, and that works very well with EBS because it offers bursting capabilities. If you need more performance than that, then customers typically move up to the next level, which is provision IOPS. So this will give you consistent performance at up to 20,000 maximum IOPS per volume and a throughput of 320 megabytes per second. So provision IOPS can be key in high-performance use cases. The other type of block storage in AWS is instant storage. These are drives that are directly attached to the EC2 host that is providing your EC2 instances. And they're made available to those EC2 instances. It's not available on all instance types. And it's rather offered to specific instance types that are designed for high-performance workloads or use cases. And the cost of these drives are actually included in the hourly price of the instance. They have, however, a couple of important characteristics. So because they're direct drive, they're physical hardware, hardware failures can result in data loss for you. So this is something that you would have to mitigate and manage, right? You would have to deploy some level of data durability yourself to counter the fact that you're running a lot closer to the actual hardware on their data, a lot closer to the physical layer of your storage. The other important characteristic is that if you issue an API call to us to stop that instance, and then issue later on another API call to start that instance back up again, your EC2 instance will come up on a different physical host, and you will lose the data that is on that instance storage. So key here is that it's only if you're actually initiating those actions. Now, it's fine to do a soft reboot, so that works. You're not going to lose data in that cases, but if you actually stop it and then start it back up, you would have to mitigate somehow or repopulate your data. And finally, these volumes are allocated at launch. But they can also provide very fast disk I/O. Without having to go over the networking, finally, we've seen yesterday that the new instance types, the new i3 instance types have been announced that have a lot of high performance SSD-based storage. These instances can support up to 3 million IOPS. So very, very, very high performance. So before we continue, how do you optimize your SQL Server storage today? Ideally, you would start from the workload itself, right? You try to understand what the workload needs are through either benchmarking or load testing, or you might be profiling your queries, or if you're migrating a workload from a data center, you would have some level of information as far as what the performance needs are in terms of throughput, in terms of IOPS, in terms of all the other characteristics. And this is no different in AWS, so planning for the performance and understanding your workload is key. But that said, there are a couple of things that we can recommend whenever you are planning to deploy SQL Server on EC2. First of all, we talked about EBS optimization. Make sure that if it's not enabled by default, you do enable that feature. And then pick an instance type that can support the level of IOPS and throughput that your workload needs, specifically if you're using EBS volumes. So different instances will provide different levels of EBS optimization. It's all documented on our website exactly how many megabits per second in terms of throughput they support. So you want to make sure that your instance first is not the bottleneck itself. And then you want to take the storage volumes that you're provisioning and format them with 64K allocation unit size. This is because SQL Server generally, on average, will issue 64K I/O to the disk subsystem. It's not just 64K I/O. It may issue some I/O operations that are smaller or larger, but typically it averages somewhere around there. So matching the allocation unit size on the storage subsystem to that makes a lot of sense. And then you can also consider striping multiple EBS volumes, with even provision IOPS volumes, to maximize the throughput that you need on that actual instance beyond just the maximum volume performance levels. And then you want to create a single volume for data and log files. Now, this might be a little bit counterintuitive, especially coming from data center where, the recommendations sometimes are actually the opposite. In a physical environment, you typically have different devices with different channels of I/O, so it makes really a lot of sense to kind of segregate that out. But in AWS, you only have a single dedicated channel for storage I/O. So unless there's any other reasons, organizational, for example, where you want to segregate different users in a multi-tenant architecture or some other types of considerations, you probably want to put everything in a single volume. Segregating that out is not going to necessarily get you any additional performance. And here what I have also here is an example volume layout that we see fairly consistently with customers, right? So you're going to have most likely a C drive, which is a boot volume. This is general purpose SSD. It doesn't require a lot of performance. It's just software on it. It requires burstable amounts of performance whenever the instance boots up, which is perfect for general purpose SSD. But nothing else in terms of data will be stored there, just application code. And then you're going to have a different drive, a D drive, that stores your data and log files. With provision IOPS at the high performance level, most likely with provision IOPS, either as a single volume or a striped set of volumes if you require that level of performance. And then you'll likely also have an E drive there that's used wherever you're dumping your backup files. And that can be a magnetic volume, either ST1 or an SC1, because reading and writing those backup files is generally a sequential operation. So you can benefit from the performance optimizations, those types of volumes, to get those activities done quickly. And then finally, you would put tempdb on instance storage, if instance storage is available. Now, if you're looking at kind of this architecture, this gives you the ability from a backup perspective to actually do two different things. You can choose to use the backup volume as a temporary storage, cache of sorts, and then ship those backups away to S3 for long-term storage, or you can as a backup strategy, use EBS snapshots just to snapshot those volumes as your backup strategy. So you actually have two different paths there, depending on your needs. Typically, if you do EBS snapshots, that's the entire volume. But if you're any time in a situation where you probably want to pull different backup files and load them up in different other places, it might be easier to just ship them off to S3 and then access them from there. And then finally, from a performance point of view, with this kind of a configuration, really about 90% of your I/O should be allocated to that D drive over there. So whenever you're sizing that system, make sure that the most amount of performance is allocated and reflected into that D drive. This is an example volume layout, but okay, what happens if you don't actually can't use EBS, right? Where your performance is such higher that you will actually need the I2 instances or the new recently announced I3 instances. So in that kind of a scenario, you would simply stripe and probably replace that D volume drive with actual instance storage. You would just have to manage your backups and your high availability in such a way that if there's a hardware failure, either at the drive level or at the instance level, you can immediately fail over to a different node in a cluster. And then obviously you can still have the backup files on network storage, so you can do individual database recovery or, protect against things like, rogue admin or somebody accidentally corrupting your data. And since we're talking about tempdb, I mentioned you want to move that to instant storage where that's available. And here are some of the instructions that you have to do kind of to move that tempdb off. So it would be an alter database temp statement providing a new file name on the new instant storage volume. And you would have to also grant the SQL Server service account access to that instant storage volume. And while you're at it, make sure you use multiple tempdb files. So SQL Server uses round robin, spreading load equally on those files in the group. It eliminates contention if you notice that tempdb actually is one area where you actually see contention. The recommendation from Microsoft is to have a one-to-one mapping with CPUs all the way up to 8. But you can actually go higher than that even if you're still seeing I/O contention at that level. And like we mentioned before, just like you can stripe EBS volumes, think about striping multiple instance storage disks together to get even more performance. Now, one thing that happens whenever you're leveraging instance storage is those volumes typically get initialized by our EC2 config service, which means that they may not be initialized and formatted by the time SQL Server normally starts up. So you want to either change the startup for the SQL Server service to a delayed start, or you can use a scripting approach to make sure that you launch that SQL Server service whenever your instant storage volumes are initialized. And we have actually a partner of ours from New Zealand, IFM, actually built a script that can fully automate that for you. It's a PowerShell-based script. They'll take the instance storage, they'll stripe it together, they'll format it, and they'll launch and configure SQL Server to use that. And the slides will be, by the way, available on SlideShare later, so you can get that link. So we've talked a little bit about high availability. From a high availability perspective, I can't stress out enough the key advantage that multiple availability zones offer. This is really game-changing. You can not only tolerate instance-level failures, but entire data center failures. And the latency between availability zones is low enough to pretty much make synchronous replication the norm for these types of deployment. And the options you have really depend on the edition. So for Enterprise Edition, we recommend using always-on availability groups. This is a feature that's only available in the Enterprise Edition. For standard edition, you can implement failover clustering using a partner-provided block-level replication solution. So AWS doesn't natively support shared volumes. So you leverage a partner that simulates that shared volume by simply replicating the blocks between two different EBS volumes. So here's a basic always-on availability group setup. There's 2 nodes in 2 different availability zones. The cluster is configured using node and file share majority. It's not depicted, but there's an actual file share in your configuration somewhere. Most likely should be in a separate third availability zone if it's available. And there's a single availability group listener, DNS endpoint, that Windows Server failover clustering manages for you. So there's 2 key configurations there. One of them is register all providers IP, which is at the listener level, which can be set to true or false. And what that really does is it either publishes in DNS all the IP addresses for all the nodes in the cluster, the synchronous nodes in the cluster, or it publishes just the principal node. And then there's another configuration at the client level, at the client connection level, multi-subnet failover that can also be true and false. So for best failover performance, you want both those things to be true. The only thing is multi-subnet failover is only supported in .NET 4.0 and up. So if you actually have a legacy application, you don't want to set both to true. You actually want to set both of them to false. If you leave register all providers IP on, then what the system's going to essentially do, what the client's going to do is just sequentially go through all IP addresses that it got from DNS and try them in one after the other, which can potentially result in a longer failover, and it will take longer for it to discover what the new master, what the new principal is. Then if both those things are false, and if both those things are false, there's only one IP, and it also only needs to wait for a single DNS refresh, which could potentially be faster. You can also extend this HA solution by deploying an asynchronous replica in an entirely different region. And this would require a VPN connection between the 2 regions, so the 2 VPCs can talk to each other over private connectivity. But this gives you DR capabilities in addition to high availability. There was actually another presentation earlier this week, Windows 403, by Scott McDonald on this specific topic. So the recording of it and the slides will be available shortly on YouTube. So they're describing this particular scenario as a ways to actually migrate data. So what if you're not actually using Enterprise Edition and you don't have access to Enterprise Edition? So for folks running Standard Edition, you can use SIOS DataKeeper Cluster Edition to simulate that shared storage. So you're going to have 2 distinct EBS volumes. They are seamlessly replicated at a block level. And that gives the appearance of shared storage, so you can actually implement failover cluster instances. Now, for some of you who ask, SQL Server 2016 actually supports always-on availability groups in Standard Edition. They call that feature basic always-on availability groups. We feel that this is probably a better solution, and the reason for that is basic availability groups only actually give you the ability to fail over a single database. And you still wouldn't have access to the secondary, so the secondary is not available for reads. It's only as a failover target. And finally, the last topic I'd like to cover for SQL Server on EC2 instances is instance file initialization. So normally, database and log files are initialized to override any sort of leftover data that's on disk. This causes some database operations to actually take longer. instant file initialization actually reclaims that disk space without actually zeroing it out. There's a couple of security concerns to do that. So deleted data is only overwritten whenever new data is written to the disk, which means that theoretically that data is accessible to unauthorized users or unauthorized processes or principals until it actually gets overridden. Normally, that's not a very high threat because the SQL Server, those database files are attached to the SQL Server process. So only the administrator or the service itself can actually access them. So the threat level is reduced during that time. But then if you decide to detach them or any sort of backup files or any sort of situations like that, that changes a little bit that equation. If this is a significant concern to you, then you obviously want to maybe disable instance file initialization or make sure that you always kind of apply very restrictive policy, ACLs, discretionary ACLs to those files to ensure that even when they're detached, they're not actually accessible by unintended users. And you can enable this. Thankfully, SQL Server 2016 has made this a lot easier. There's a simple checkbox in the install wizard. But if you're in a position to not use SQL Server 2016 or you've already installed it, then you can actually go in the local security policy application and then simply grant the SQL Service account the perform volume maintenance task. So a lot of these recommendations that we kind of discussed involve OS level access. So in RDS, because it's a managed environment, you don't typically have this type of access. And we handle the instance, the engine and instance configuration for you. So while some of these concerns are similar with RDS, there are a few differences. So in the remainder of this session, we'll cover a little bit some of the specific concerns that we hear from customers around RDS and how to optimize that. We'll also focus on storage because storage is important and is, again, a very top ask from customers in RDS as well. But we're also covering data movement and migration, high availability, as well as Windows authentication. So your data, just because it's a managed service and it's a managed environment, your data isn't locked into RDS SQL Server. There's many ways you can actually move that to and from RDS. New this year is the ability to import and export backup files using SQL Server's native backup functionality. I'll cover this in a little bit more depth shortly. You can also use the tried and true classic method of downloading flat T-SQL files and then loading them back up. This works for small databases and in situations where you actually just, you can afford to take a little bit of downtime because typically the load back is a single-threaded application unless you kind of parallelize it yourself, so it can get complicated. And, the amount of downtime you're taking, unless you want to manage data change, can be higher. So for more advanced use cases, we can leverage the database migration service. This will provide you an environment where you can minimize downtime during any sort of migrations. You can also migrate between different platforms, from any other database engine to SQL Server potentially. So this works for situations where you have to do the initial data load, and you can actually also do change data capture to replicate any sort of changes from a different system into RDS. Change data capture is not yet supported outbound with RDS as a source. And we also have a schema conversion tool that can help potentially with converting schemas if you have to move data from one database engine to another. Service itself is also highly available. So in an environment, you could potentially leverage RDS SQL Server as a read replica for a EC2-based cluster. And the data doesn't have to actually be in AWS. So your sources or your destination of the data can be EC2 instances, RDS, or even on-premise servers. And then finally, you can leverage the AWS marketplace, where our software vendors, partners, they offer third-party data movement solutions that may fit specific type of use cases that are more optimized for different types of workloads. So to use native file import and export capabilities using back files, you have a couple of prerequisites. The first one, and I know it's obvious, you need the actual RDS SQL Server database instance. You also need an S3 bucket. Remember, RDS doesn't actually give you access to the file system. So you'll be interacting and retrieving or loading the files through S3, through an S3 bucket. And you also need the database option group that enables that feature. So option groups in RDS are a way to kind of centralize configuration and the features that are available for a database instance. In this case, a feature that you need to enable is SQL Server backup and restore. And while you enable that feature, there's a couple of different things that you need to provide. One is the name of that bucket, right? So the bucket that you're going to be using, as well as a role that RDS can assume so it can get access to the ability to read or write from that bucket. And finally, an encryption configuration, whether you want those back files to be encrypted while they're delivered to S3, and which keys you would like to use for that. And then finally, you need a client that you can connect to that database instance to actually execute the stored procedure. So because, again, it's a managed environment, you can't quite do it through the SQL Server Management Studio point-and-click interface. We offer stored procedures that you can easily execute to initiate those jobs, track those jobs, and potentially cancel those jobs. So here's an example of the types of stored procedures that you would run. So you can use a stored procedure to restore a database. You provide the database name and the file location in S3 that you want to use. You can export to a back file. Again, you provide the database name, the file, and the option of whether you want to overwrite a previous file or not. There's also a store procedure that you can call to track the status of those jobs. And there's another one not displayed that you can use to actually cancel any of those jobs. So it's really easy and fairly intuitive to use. There's not a lot of parameters that need to go on. It can be easily scheduled with something like SQL Agent if you want to take backups on a regular basis and dump them, for example, into S3 directly. So from a high availability perspective, unlike on EC2 where you have to kind of set that high availability up yourself, it's all managed in RDS. We have a fully managed hands-off solution where you deploy database instances in multi-AZ. Okay, you notice the same pattern, multiple availability zones. It's really, really key to our high availability strategy. So this feature will deploy two identical database instances, a principal and a secondary, in different availability zones. It leverages synchronous SQL Server database mirroring technology to replicate the data from the principal to a secondary node. And in the event of a failure, the secondary instance is made available for continued operation. Now, before you're wondering, yes, there's actually a witness available in there as well, in that configuration as well, for quorum purposes. So multi-AZ mode is designed similarly like we discussed in EC2 to mitigate failures at both the instance and availability zone level. With RDS, your database instance is exposed using a DNS endpoint, right? So you use a SQL client to connect to it to that DNS endpoint and the port. And we manage that endpoint and the IP addresses that it resolves to. And in the event of a detected failure, we stop DB mirroring, we promote the secondary to a primary, we remap the DNS endpoint to the IP address of the new primary and provision a new secondary. The DNS endpoint actually has a time to live of 60 seconds. So the whole process really can be done from failure detection to recovery, take a few minutes. All your application actually has to do is implement some level of retry logic to try to retry the database connection until the service is restored. Now, when you do implement retry logic, make sure you do implement some level of backoff strategy as well for optimal connections, because otherwise you're running into a situation where everybody else is going to slam the new server, which might potentially impact your performance initially as you're restoring service as well. And you should test the ability of your application to fail over by triggering a manual failover. So that's an option that you can do through the console or our APIs. It will essentially trigger a failover. And you can use that to test your applications and make sure they can actually tolerate it. This is really, really important. I often talk to customers that are in a failure scenario only to realize that we're confident that their application can tolerate such a failover, only to realize when it actually happens that something somewhere, cached or something, some little routine didn't get triggered in their application, or in any way, they ended up in a situation where even though the database failed over correctly, their application did not recover correctly. So use our capabilities to test, and test frequently. Now, because we rely on Microsoft's database mirroring technology, it is important to understand that write-heavy workloads may see a performance impact, right? So because the writes have to be confirmed by both the principal node and the secondary, you're actually traveling over the network. That adds latency, so that might impact your performance. But furthermore, because mirroring might actually result in higher I/O on your secondary node than your principal node for write-heavy workloads or whenever you have spikes of that. So one thing that I recommend customers look at, if they see slowdowns in their application, they can't attribute it to the principal node, either in form of I/O or CPU or memory bottlenecks, consider the secondary node. So it might actually be a situation where that spike of I/O generated a lot more I/O on the secondary as your logs were written, as your changes were applied to the database, and that could have impacted your performance. Because, again, remember, it's synchronous replication, so a write has to wait until even the secondary actually confirms it. So if that one is overloaded, that'll take longer. So plan storage accordingly, even for that kind of a situation. And since we're talking about storage, the I/O performance options that you have on RDS are similar to EC2. You have general purpose SSD, you have provision IOPS. We actually offer them legacy magnetic storage in RDS as well. The maximum amount of storage that you can provision in RDS is 4 terabytes and up to 20,000 IOPS for the entire database instance. Again, most folks start and look at provisioning RDS instances with the general purpose SSD, that row all the way in the middle. But, obviously, provision IOPS becomes a very good choice whenever you are actually kind of needing a high performance and you're kind of at the point where you see that your workload is actually bumping up at the top performance levels of the general purpose tier. One thing you cannot do today with RDS is scale the storage. So you want to plan ahead. from the beginning about how much storage you will need and the growth of that storage over time for as long as that instance lives. In the end though, obviously every workload is different, so we recommend you do benchmarking, you do load tests, and figure out what the performance needs of your application are. Now, this is really where things like that are really cost effective in AWS, because with the licensing included model, you can spin up a RDS instance, run it for a day, run all your benchmarks and load tests and so on, and then shut it down. And all you've paid from a licensing perspective is for those hours that that instance was running. And as with EC2, I find that effective storage I/O planning can be most impactful to actually increase and optimize the performance of your SQL Server installation. Your throughput, as with EC2, will depend on the database instance class that you're picking, much in the same way that the total throughput depends on EC2 instance type. And now RDS supports a maximum of up to 20,000 IOPS. And while this is typically a very common indicator for the capacity of concurrent I/O that your system might be capable of, it may not necessarily be the leading indicator as far as if you're having performance problems. So one thing, I/O requests for provision IOPS can handle up to 256 kilobytes in I/O size, but they're measured at 32 KB, and everything above that will be represented as multiple I/O operations. Now, coming back to kind of SQL Server, who kind of likes 64 KB operations, you're actually in a situation where you may not actually maximize on IOPS whenever you're running into issues, but you might actually fully maximize the throughput of that storage or of that database instance class or of the storage that you've allocated, not the IOPS. So I find that the best indicators for understanding whether your storage subsystem is behaving correctly and it's providing the right level of performance are obviously your I/O latency and a metric called average queue depth that is available in CloudWatch. So this metric, average queue depth, represents the number of I/O requests that are waiting in a queue, waiting to be serviced by the storage subsystem that is busy handling other I/O operations. If that number is 0 consistently over time, that pretty much means that your system doesn't actually push enough I/O through it to saturate the storage subsystem. So it could be an indicator that you're over-provisioned, you've allocated too much performance or too big of a volume. Or it could be an indicator that your performance issues, if you're still not happy with performance, aren't actually at the storage subsystem layer. They're probably somewhere else higher up in the application stack. If that number is positive in nature, but it's a low number, and the current guidance is roughly around 5 outstanding I/O operation per 1,000 IOPS, that means that you're effectively using the storage subsystem. You're actually pushing enough I/O to saturate the storage subsystem, and you're keeping continuously pushing that much I/O that it's not just a simple blip. But if that number is really, really high, that's a perfect example of you're actually trying to push more I/O through the subsystem than you can handle. So that's a good indicator that there is a performance issue with your storage. Finally, I'd like to spend a few minutes highlighting the Windows authentication capability and the feature that we launched earlier this year for Amazon RDS for SQL Server. So just like Some of our other Active Directory integrated AWS services, such as WorkDocs, Workspaces, and some Workmail, and the integration with our console, the capabilities provided by AWS Directory Services. This is a sister service to RDS in many ways, in the sense that just like RDS is a managed service for SQL Server database engines, Directory Services is a managed service for user directories. Microsoft Windows Active Directory is one such option there. And whenever you want to leverage Windows authentication, you have to spin up a directory service, a Microsoft AD directory service. And your RDS database instance will actually be joined to that domain. Now, you can use that domain and assign users to it, join your other servers to that domain. It's available for that. But the reality is that a lot of the customers that I talk to, probably most of you already have well-established Active Directory deployments in your organizations. So what such customers do is they essentially establish a forest trust between their existing Active Directory and the RDS and the directory service provided by AWS. This will allow users in your existing Active Directory from servers or computers that are joined to that domain be able to connect to your RDS database instance with their credentials and leverage Windows authentication to access resources on the SQL Server. So the simple way to set that up, you would have to configure an inbound trust on the external forest, on your external domain, and an outbound trust on the directory. And you also configure conditional forwarders for the two domains to make sure that DNS is propagated properly between the two environments. And then you can take this architecture and extend it into a hybrid deployment, extending an on-premise Active Directory environment where actual domain controllers, your external domain controllers, are sitting actually in your own data center. So to do that, you would just kind of deploy secondary domain controller, read-only secondary domain controllers in AWS. You would connect your data center to your virtual private cloud in AWS using a VPN connection, potentially. And you can leverage the same pattern to access your RDS resources using Windows authentication. Now, that's it for me tonight. Thank you so much for your attendance. And I hope each one of you learned something today.